Welcome. Today we will see last point of this chapter number 5, that is steady state analysis and transient response, that is Routh's criteria for a control system. It is also called as Routh's array method or Routh-Hurwitz method to determine the stability of control system. Routh suggested a method for tabulating the coefficients of characteristic equation in a particular way. The tabulation of coefficients gives an array called as an Routh's array. Routh was a scientist. Consider a general form of characteristic equation as Fs is equal to a naught s raised to n plus a1 s raised to n minus 1 plus a2 s raised to n minus 2 plus a3 s raised to n minus 3 plus dot plus an s raised to 0 is equal to 0. The array of coefficients of above equation are formed as s raised to n, s raised to n minus 1, s raised to n minus 2, s raised to n minus 3 dot s raised to 0. Now a naught, then you have to write a2 like this. A naught, then a2, after a2 you have to write a4, after a4 you have to write a6 like this. Then s raised to n minus 1, its coefficient is a1, write a1 here. After a1 you have to keep that nearest and you have to take one by one. A1, after that a3, after a3 you have to write a5, after a5 you have to write a7. Similarly, now s raised to n minus 1, b1, b2, b3, c1, c2, c3 and s raised to 0 an. Now this b1, b2, b3, c1, c2, c3 we have to obtain by using some calculations. Therefore, the coefficient of the first two rows are written directly from the characteristic equation. From these two rows, next rows can be obtained as follows. Now b1 is equal to what? a1 a2 minus a0 a3 divided by a1. b2 is equal to a1 a4 minus a0 a5 divided by a1. b3 is equal to a1 a6 minus a0 a7 divided by a1. Similarly, c1 is equal to b1 a3 minus a1 b2 divided by b1. c2 is equal to b1 a5 minus a1 b3 divided by b1 and so on. The necessary and sufficient condition for a system to be stable is that all the terms in the first column of Routh's array must have same sign. There should not be any sign change in the first column of the Routh array. If there is any sign change exists, then first point, system is said to be unstable. The number of sign changes equals to the number of roots lying in the right half of the S-plane. Therefore, always remember all the values should be positive in the Routh's array, that is in the first column. Then we can say that the system is stable. If the sign changes, then system is unstable, and number of sign changes is equal to number of roots lying in the right half of the S-plane. Therefore, this we have to remember. Now, based upon this, we will solve some problems. Example 1, s cube plus 6s square plus 11s plus 6 is equal to 0. Comment on the stability of the system. Solution. Here given characteristic equation is s cube plus 6s square plus 11s plus 6 is equal to 0. Comparing with standard characteristic equation, that is a0 s raised to n plus a1 s raised to n minus 1 plus a2 s raised to n minus 2 plus a3 s raised to n minus 3 plus plus an s raised to 0 is equal to 0. We get highest power n is equal to 3. Therefore, a0 is equal to 1, a1 is equal to 6, a2 is equal to 11 and a3 is equal to 6. Now, our standard array is S3, S square, S1 s raised to 0, A0, A2, A4, A1, A3, A5, B1, B2, C1, C2, which is equal to. Now, so we will substitute values of this A0 A2, A4, A1, A3, A5. Therefore, S cube, S square, S raised to 1, S raised to 0, 1, 11, 0, 6, 6, 0. Now this how to obtain 10? B1 is equal to A1, A2 minus A0, A3 divided by A1. Therefore, A1, A2 minus A0, A3 divided by A1. Therefore, 6 into 11 means 66 minus 6 divided means 60 divided by 6 means 10 value. 6 into 11 minus 1 into 6 divided by 6 is equal to 10. Similarly, B2 A1, A4 minus A0, A5 divided by A1 which is equal to 6 into 0 minus 1 into 0 divided by 6 which is equal to 0. Now C1 is equal to B1 A3 minus A1 B2 divided by B1 which is equal to 10 into 6 minus 1 into 0 divided by 10 which is equal to 60 by 10 is equal to 6. As no change in sign there in the first column of Routh's array, the system is stable. See that this is the first column. No sign change, therefore system is stable. Now example 2. S cube plus 4S square plus S plus 16 is equal to 0. Comment on stability of the system. Solution. Here given characteristic equation is S cube plus 4S square plus S plus 16 is equal to 0. Therefore A0 is equal to 1, A1 is equal to 4, A2 is equal to 1, A3 is equal to 16. Therefore we have S cube, S square, S raised to 1, S raised to 0, A0, A2, A4, A1, A3, A5, B1, B2, C1, C2. Therefore S cube, S square, S raised to 1, S raised to 0, 1, 1, 0, 4, 16, 0. Now we will obtain this B1 value. How we obtain this minus 3 we will see. B1 is equal to A1, A2 minus A0, A3 divided by A1 which is equal to 4 into 1 minus 16 into 1 divided by 4 which is equal to minus 3. Similarly, B2 is equal to A1, A4 minus A0, A5 divided by A1 is equal to 4 into 0 minus 1 into 0 divided by 4 is equal to 0. C1 is equal to B1, A3 minus A1, B2 divided by B1 is equal to minus 3 into 16 minus 4 into 0 divided by minus 3. Therefore, which is equal to minus 48 minus divided by minus 40 minus 3 is equal to plus 16. As there is change in sign in first column of Routh's array, the system is said to be unstable. Yes, change in sign. The number of sign changes are which is equal to plus 4 to minus 3 and then minus 3 to 16, that is 2 times. That is positive to negative and negative to positive again, that is 2 times sign changes. Therefore number of roots located in right half of the plane is equal to number of sign changes which is equal to 2. Now we will see example 3. S raised to 4 plus 6s square plus 26s square plus 56s plus 80 is equal to 0. Therefore again we will write down here s raised to 4, s raised to cube, s square, s1, s raised to 0. Therefore this vertical line s raised to 4 its coefficient is 1. Therefore write here 1. After s raised to 4 you have to take s square like this. You have to skip one term and you have to take next term. Therefore 26. After 26 you have to take 80 like this and then 0. Now s cube. Coefficient is 6. Write 6 here in front of s cube. After s cube you have to take s term. Therefore 56, 0, 0. Then b1, b2, c1, c2 and s raised to 0. 80 term is there. Therefore we will obtain b1, b2 and c1, c2. Therefore b1 is equal to 6 into 26 minus 1 into 56 divided by 6 which is equal to 16.67. b2 is equal to 6 into 80 minus 1 into 0 divided by 6 which is equal to 80. Therefore substitute values of b1, b2 which is equal to 16.67 and 80 in that array. Now we have to obtain values of c1 and c2. Therefore c1 is equal to 16.67 into 56 minus 6 into 80 divided by 16.67 which is equal to 27.21. Similarly c2 is equal to 16.67 into 0 minus 1 into 0 divided by 16.67, which is equal to 0. Therefore substitute the values of C1 and C2. Therefore we are getting Routh's array as S4, S cube, S square, S raised to 1, S raised to 0, 1, 26, 80, 0, 6, 56, 0, 0, 16.67, 80, 0, 27.21, 0, 80. As there is no sign change in the first column, system is stable. We have to see this first column and we have to check whether any sign change is there or not. Now we will see example number 4, that is last example. S raised to 4 plus 6s cube plus 35s square plus 50s plus 24 is equal to 0. Therefore s raised to 4, s cube, s square, s raised to 1, s raised to 0. Now a0, a2, a4, a6, a1, a3, a5, a7, b1, b2, c1, c2, d1. Now we will substitute the values of two rows from the given equation, that is first row and second row. Therefore s raised to 4, in front of s raised to 4 you have to write like this. You have to take here coefficient of s raised to 4 is 1, then you have to go to s square, that is 35, then you have to go to 24. Similarly in front of s cube you have to write first of all 6, after 6 you have to take 50 and after that you have to write 0. Therefore same case is here, s raised to 4, s cube, s square, s raised to 1, s raised to 0, 1, 35, 24, 6, 50, 0, b1, b2, c1, c2, 24. Therefore b1 is equal to 6 into 35 minus 1 into 50 divided by 6, which is equal to 26.2767. b2 is equal to 6 into 24 minus 1 into 0 divided by 6 is equal to 24. Therefore s raised to 4, s cube, s square, s raised to 1, s raised to 0, 1, 35, 24, 6, 50, 0, 26.27, 24, c1, c2, 24. Therefore c1 is equal to 26.27 into 50 minus 6 into 24 divided by 26.67 is equal to 44.60. C2 is equal to 26.67 into 0 minus 6 into 0 divided by 26.67 is equal to 0. Therefore substitute the values of C1, C2. We have Routh's array as s raised to 4, s raised to cube, s raised to 2, s1, s raised to 0. Therefore 1, 35, 24, 6, 50, 0, 26.27, 24, 0, 44.60, 0, 24. As there is no change in sign in the first column, this is the first column, therefore the system is said to be stable. Thank you very much. This chapter is over. Thank you.